I'm excited to talk through this feature because I've been using it a lot and really enjoying it, and I know you and others spent a lot of time on it. So why don't we just start with like, what was the motivation here? Like, what's the problem we're trying to solve?
Yeah, so we can start with by saying what we had in Zed. Like Zed for a long time has had support for Copilot and Super Maven. And support for those has been pretty good, I think. But I think there were two problems with it. Like one is out of the box when you open Zed, you don't have completion support. Like you need to sort of go through the hoops of registering for a provider, like signing up for Copilot or signing in or doing the same for Super Maven. That was one issue. And then the other issue was just like, we thought we could do something better than what Copilot and Super Maven offered at the time. And so, yeah, we just wanted to try our hand at inline completion, or as we're calling it, edit prediction. But yeah, one crucial difference between Copilot and Super Maven and this is that the model will suggest arbitrary edits, not just where your cursor is. So that's kind of interesting, right? Like, because that adds another hurdle to the UX because not only we need to display ghost text, but also we need to show deletions and like it makes it it's a lot more useful, but it makes the UI a lot more complex. And so yeah, navigating that was interesting. And yeah, and then like just this other problem of like, okay, you're typing and the LSP wants to be helpful, right? The language server is like, hey, uh, here's a list of methods that you might want to call if you're in the process of calling a method, like typing a method name. And so there's this race, right, between the model, right, the prediction model, getting back with its suggestion, and the LSP getting back with its suggestion. So how do you solve sort of which one do you show? Do you show like just one? Do you show both at the same time? Um, so we ended up like, and I think it's a pretty elegant solution that our designer Danilo and Agus came up with, which is we end up showing both, and like they're sort of in this it looks like the same menu, but like the LSP completion is a little bit detached from the edit prediction. And again, using the same modal behavior, like you hit option and you opt into like uh looking at the edit prediction as opposed to the LSP completion. So I don't know, I think it's really cool. Like nothing I've never yeah of course, before implementing this, we tried other implementations of this feature. We're not the first. Cursor implemented it as well, but I'm really satisfied with the UX that we came up with.
You mentioned earlier that there's these non-local edits, right? So it's
Right.
not just whatever writes is right after your cursor. And
Right.
this is one of those features where I think if you described it to me, I don't know if I would think it sounds awesome, but it's totally awesome. Because it's like it lets you be typing something up here, and then it's like for example, let's say you change a variable name from like singular to plural, like it was. I think in our demo video we have like root changes to roots, and it's like,
Hmm.
well, with a normal editor experience, I could do a rename, but that doesn't take care of the fact that it's like, well, yeah, but now it's an array, whereas before it wasn't.
Right.
So how do you deal with those implications? And the cool part about the non-local edits is that it can be like, oh, you changed the name and the type here. Let me just go change like, oh, somewhere down below, you were using it as a singular thing. Now I'll change the name, but also I'll wrap it in an array, or I'll get like, I'll change,
One
see
of
if
my
it's
favorite refactorings is, in GPUI, we have this thing called context spawn. It's similar to how you spawn a task in Tokyo. It's a very simple kind of refactoring, but I love that I can just, I have a block that I want to spawn and send off to a different thread. I'll just put my cursor above that block and say CX spawn, and Zeta, the model, will just be like, okay, I'm going to wrap this up for you into an async move, and then like close the parentheses accordingly. It's just, I don't know. It really, I don't know. Sometimes it feels like it's reading your mind. I don't know. It's cool. It's not always perfect. Obviously, I'm not claiming that it's we
right.
invented AGI, but it is really helpful, especially when you need to do like repetitive refactorings that like you have a hard time expressing with a regex or a find and replace. Like it really gets how to manipulate the text in a way that it would be hard to do in a mechanically.
Right, and the thing I love about it is that it feels like it's reducing the amount of code that I'm writing, and specifically, it's reducing, like, the most annoying type of code to write.
Right.
It's like it's like, this is mechanical, and it's, like, something that I'm just gonna go through, and it's kinda brain dead to just, like, keep making the change, but it doesn't quite fit into just, like, a rename. It doesn't quite
Right.
fit into a regular expression. It's like, you could describe to someone how to do it because it's just so straightforward, but it doesn't quite work with any of our previous tools, and it's like, "Oh, now you actually have something where you actually can just be like, tab, 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 done." Whereas before you'd be like, "Alright, do that on this line, do that on this line," or this is something that I used to do, Vim macros for a lot, and now I don't
Mhm.
have to do much Vim macros because and
Yeah.
of course, with macros, it's like you have to put this big upfront investment in, and you have to be like, "Oh, I hope I get the macro just right because if I'm off, I can't do it, or like it's not gonna quite work." And now it's just like, "Oh, tab, 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 done." Now I can move back to the interesting parts of programming.
Yeah. Yeah, totally. Yeah, to be fair, like, before this, I didn't use Copilot or Super Maven. I found them helpful, but yeah, I don't know. The fact that you can edit not just where your cursor is, but like at other spots, I think makes all the difference. It's like, I don't know. It's a very different experience. Like you're doing a different thing. You're not, it's a different feature almost.
Yeah, I agree. I mean, it definitely feels like, and I think Copilot recently announced, like within
Oh,
the
yeah.
past, they're adding
Yeah,
that because yeah, I think once you've tried it, it's just sort of like, yeah, this is the most useful aspect of this feature. It is the like repetitive multi-step thing where you normally have to jump
totally.
around and move your cursor and so forth.
I can talk a little bit about the whole process, like how we started. Because like the basic idea was, because all these models, like by default, they ship, or many of them ship with what's called fill in the middle. For example, you download Qwen 2.5 Coder, which by the way is the model that we ended up fine tuning. Spoiler alert. But like you download that, and it already has support. It's already been trained on fill in the middle. So you know, Copilot V1 style, right? Where you can only insert stuff, right? So you have these specialized tokens that you can insert into the text, and you can say, okay, this is my prefix, this is my suffix. I want you to fill right, in the middle here, right? And the model starts replying as if you know it's continuing from that spot where you wanted to fill at, right?
Right. The
Um,
special token is some like really weird string that would just never appear in code. It's got, like it's
right.
like pretty long and like, yeah. And I
Yeah.
think a reasonable question to ask is like, why not just use something like Claude 3.5 Sonnet, which is like everybody seems to agree, like it's the best for code. Like, why settle? Why go with this other model when you could
Yeah.
just like
I mean,
Claude?
yeah, it's a great question. I think there were few reasons for it. One is latency. Like I think trivially, it's just very very hard to because yeah, we ended up using this idea of like rewriting a snippet of code, and so like you can get Claude to do it pretty reliably, and it works probably very well. I mean, we do this all the time when we do control enter in Z, right? Like the inline transformation. Uh, but it has a very different latency characteristics, right? So that was one reason. The other reason was just having full control, like owning the infrastructure for it. For it means that we don't have to worry about rate limiting. We don't have to worry about relying on another provider. We I mean, as always with Zed, like we like controlling what we do. Like we ended up writing our own UI framework for that. So like that's kind of in the same spirit. So yeah, I think those would be the two things, and then yeah, like being able to run a smaller model because like you don't need a ton of intelligence to like suggest the kinds of edits that we wanted the model to produce,
Right.
right? Like it doesn't need to be as clever as Claude is, or as O1 or O3 is, right? And so
Or
yeah,
deep,
just
I mean,
or
DeepSeek is
DeepSeek, right?
now could run on our own hardware, but yeah, it's kind of like big model, big latency is kind of the
Right.
default. Like,
Yeah, yeah. Now, like you start having like hundreds
yeah,
of billions of parameters. Now you need to run it on multiple GPUs. Like it starts getting a little trickier. And yeah, for this particular task, we didn't need that many neuron connections, right?
right.
Um,
But we do want it to be fast. Like you want
but we
as
want
your
it to be fast.
pops up, like you don't want to be like, I finished typing and then like it suggested something from like a second
Totally.
ago. Like, too late. I've moved on.
Right, right. And so we ended up going with basically two techniques that work kind of. together to deliver the latency that we have in Z. So the first technique is just, I mean, the basic idea that we wanted to try and that we experimented with was, as opposed to using this like weird prefix suffix syntax, can we just get the model to take a snippet and rewrite it, incorporating the next prediction, right, or the next multiple predictions? And partly this partly comes from the experience of um, when we implemented control enter and line transformations, that like we also tried at the time having the model sort of generate edits, because like as a programmer, like the first thing I thought about was like, okay, like the best representation for this is for the model to give me edits, right? Tell me what I need to change, and I
Right.
will deterministically apply those. And we found out
Diffs,
that, oh, go ahead.
diffs, right? Like, yeah, like essentially like insert here and then delete here
Right,
and then
exactly. And that at the time didn't work very well, even with like the larger models. I think nowadays you have like, I think Claude has like certain tools that you apply edits. So things have changed since then. But yeah, especially for these smaller models, that generating edits was not an option. And so what we thought was like, okay, take a snippet of text, rewrite it. Here's a bunch of edits that the user made, right? And here's a snippet of text. Just rewrite it to incorporate the new changes that you want to apply. So that was one bit. Uh, but that alone, even if you use a small model, is not going to give you great performance, just because like it's still generating tokens. Like, I don't know, I still don't have like my mind fully wrapped around like how fast you can generate tokens, especially if like from even on an NVIDIA H100, like it depends a lot on like the throughput that you want, the latency that you want. Um, but yeah, basically what we ended up doing was using speculative decoding. So like the key idea is whenever the model is suggesting an edit, for the most part, like 95% of that code is not going to change. Like it's going to be exactly the same. So um, we can use this technique called speculative decoding. And there's several ways that you can implement speculative decoding. We're using n-gram speculation, where like we tell the model, hey, this is the snippet we want to rewrite. And by the way, you should try to like guess that the output that you're going to produce is very similar to the input in this case, right? This input excerpt. And so the model can just be like, as opposed to, because these models are autoregressive, right? Like you generate token n, and then to generate token n plus one, you need to generate, it's like linear, right? Um,
yeah,
Whereas with speculative decoding, what you can do is you can speculate, assume that, okay, like if the next 20 tokens, I can sort of skim at the uh at the at the input. Well, then like I can sort of assume that you know that basically these tokens are going to be the same. So what you end up doing is like you can generate multiple tokens in parallel, like
right.
as opposed to waiting for the previous one to appear. You can just say, okay, let me assume that this token is the one I'm seeing in the input, and so I'll generate the other one. And so you end up like, yeah, parallelizing the generation of tokens. And when the input and the output are very similar, you get the latency, to in the hundreds of milliseconds, which is what we ended up
Right.
having.
And some of the speculative decoding might turn out to be wrong because there might turn out to be
Right.
like an insert in the middle there, and then it either
Right.
has to like redo some work or like fix up in like kind of shift things
Right.
over. This is the same thing that CPUs do basically for
Right.
like
French prediction.
exactly, yeah. It's the same basic idea, and like it
Right.
speeds up CPUs and it speeds up
Right.
language models too. Um,
It's
I was,
fascinating.
I was thinking about it. It's funny, like you're mentioning this, and it's like we can just talk about exactly how we did it because we open sourced everything. So like
Right.
anyone, this is not a secret. We actually don't know what like Cursor and like Copilot and them are doing because they didn't open source everything.
Yeah. Um, but yeah, like the first thing that we tried was, because like the backstory of the project was that, okay, what's the simplest thing that could possibly work, right? And what we did was to start with prompt engineering, like literally, you know take the model, ask it, hey, these are the edits, this is the excerpt, please rewrite it. And that worked well for a while. Like we had our set of evals, right? That, and maybe we can talk about that in a second. But basically,
Yeah,
like we had our tests, right? And like we were able to make 5 or 6 of them pass pretty consistently. But as soon as the more complexity we added to the model, meaning like we wanted the model to do more things, the flakier like it got. It was very very hard to like add new stuff without breaking the existing stuff. If that makes sense.
Yeah.
Um, so like we tried, and we even I think at the time when we tried was to use Quen 2.5 coder 32B. Like we used the biggest model that we could possibly use, and even then like the model would just trip up. Like it wouldn't remember to do all the things that we wanted it to do all the time. So yeah, that's when we took a step back and we were like, okay, we need to look and do something else, and that's where we started experimenting with fine tuning, which was this was the very first fine tune of Z Industries.
Yeah. Yeah, it's funny because like that is something I've noticed with prompt engineering, where you're sort of trying to just like tweak the exact wording of like exactly what you tell the model to do, and sometimes it fixes the problem, but other times it just makes it over index on a particular use case,
Right.
especially the more complicated and specific your instructions end up getting. And yeah, like especially in a context like this where what we're giving the model is, I think, what is it, 32 lines of context like on either side of the where the cursor is.
We changed it to be expressed in terms of a token approximation. So right now the model rewrites 400 tokens. I think it's hard coded too.
Right. So it gets to see a little bit before your cursor, a little bit
Right.
after your
Exactly.
yeah, of like context. And so it's not, it doesn't have a lot to work with. And so, you can try giving it more specific instructions, but like you said, what ended up seeming to work a lot better is to fine tune the model based on like being good at that exact scenario.
Right. Right. Yeah. And like making the model see like tons of because you could put all those examples in the context window, right? But now you're okay. Now the model has to like I don't know. It gets confused. It's true that these models are getting bigger and bigger context windows, but it's also true that the bigger it is, like the less attention the model can pay to like the earlier stuff in the context window. There's like a recency bias.
And I've
Um,
heard like, even though you have a model, let's say it has like, a couple 100,000 or even a million tokens that are technically in the context window, it's like in practice, after you start giving it like 20 or 30,000, like the quality of the response just starts to degrade.
yeah.
And so like, what's the point? It's like, yeah, you could give it like a million tokens and get a totally garbage response, but like what I wanted was a good response. So
Yeah.
what's
Yeah. Yeah, I think like maybe the newest models are getting better at that. I'm not 100% sure, but definitely like the the edge models that have been published recently. I think they've gotten better at it. But yeah, definitely like it's not perfect. Like they're good at recollecting stuff, I guess, but like it's tricky to sort of apply whatever they recollect to the new output. So yeah, that's where we're like, okay, um, you know, we can't do prompt engineering on this. Let's fine tune. The problem was that we didn't have any data. Like we um, we didn't, yeah, literally didn't have. We had some examples that from the evals, right? Like sort of, we knew roughly like the kind of data that we wanted, but you need to have like for fine tunes, you need to have in the hundreds of examples at least. I mean, ideally you have a lot more, but at least a few hundreds.
And these
Um,
examples are like like literally here was the input, like the cursor was here, and then here was the context that we gave it, and then
right.
it gave this output, and it's like, was that a good? Did it do a good job? Yes or no?
Right, exactly, and like, yeah, because that's how, yeah, it was a learning process for us as well. But yeah, basically, like, you have to show the model, hey, given this, do that. Given this, do that, and you show it enough times, and the model sort of learns and approximates this sort of edit prediction function, right? That we wanted it to learn. It's pretty fascinating. I think like this was one of the first times for me where I was like, okay, this I don't know. I was excited about AI before, but I think fine tuning gave it a whole other spin to it for me. I don't know. It was pretty interesting. So yeah. Anyway, like we didn't have those examples, and so but we wanted to like start as soon as possible. So what we did was um and I think that's how the way that this is referred to in the literature is like knowledge distillation, sort of, or in this case, it was synthetic data. Basically, what we did was, okay, like we don't have any data, and like we want to start the fine tuning process as soon as possible. let's just have a bigger model generate, come up with examples of, you know, plausible patterns, right? And that's what we did. I think like the first, if you look at the data set, which by the way is also open,
Yes.
and yeah, feel free to play with it and help us there. Would love your help. Yeah, basically like I think the first 50 examples or something were generated by Claude. I think. So yeah, like I remember sitting down and being like, okay, now generate a Ruby example where you do this but not do that. Yeah, basically I came up with sort of the scenarios, right, and had the model generate plausible, real world pieces of code. So we bootstrapped that process with those synthetic examples, and then in the meantime we also added data capture for staff, right? So like all the Z engineers would sort of, well, okay, yeah, they had the ability to sort of report feedback for the edits.
Right.
So yeah, like sorry, back up. We we bootstrapped this model. We deployed it, and so like we gave access to Z staff to this, right? And then we added a feature that it's actually under a feature flag, like yeah, most people cannot see it, I think, where like you could rate a completion. So like or a prediction as we later called it. So you could sort of use the model and be like, okay, like I really liked what it did here, and I really hate what it did there, right? Or uh, you know, it didn't do anything in this case, but I expected it to help me do this other thing, right? And so like we all those pieces of feedback would go into Snowflake, which is our data lake, data warehouse. And I remember basically like every day, Torsten and I would kind of sit down and be like, okay, we got 20 new pieces of feedback. Let's see. This was good. This is kind of unclear. I don't know if I want to show this to the model. Let's leave that out. Or other pieces of feedback were like, oh, actually, I'm on the model side, right? Like I don't think the user understood what the model wanted. Basically, yeah, sort of discarded the user feedback. So yeah, like that was in the beginning how we did it, and
And there
um
was some interesting some trends there, right? So like I remember like there a couple of common things that people I remember we were discussing it online. Like people would say like, "Oh, I just like deleted something," and the model was like, "Did you want to re-add that?" It's like, "No,
yeah, yeah,
I did it on purpose."
yeah,
Or,
yeah,
uh, or like cleaning up white space, where it's like, "I don't suggest that to
yeah,
me." Like
yeah,
the model is
man.
going to take care
Yeah,
of that.
the initial version I think had this terrible behavior where I don't know where it picked it up from. I think it was just too few examples, like where it would just delete a block of code. Like at some point, it was just like, okay, I give up. Here, like I'm just gonna rewrite 20 lines out of 50, but we would interpret them as like, oh, the model wants to delete the remainder. Whereas I think what the model learned was just like, okay, I can stop because I had nothing to suggest after this. So yeah,
Yeah,
like yeah,
it looked like the model was like, "Hey, do you want to just delete this whole function?"
yeah, just
Maybe
just
I'll do it. Like,
yeah, just delete it, man. Yeah, yeah. So that was at the beginning, and then like what we ended up doing was because like we weren't getting enough feedback. It was really good, I think, to kind of pinpoint the behavior of the model, sort of like at a higher level, like just knowing exactly which kinds of refactorings we wanted, but it wasn't very good at like giving us the diversity of data that we needed because people, it is a bit annoying for someone to be like, okay, I like this prediction. Let me stop, go into this thing and like report it, right? So what we ended up doing was um for staff, for the Z staff, we would all the completion would just be reported to Snowflake. Like we would get them all. Which, you know, I think overnight I mean, if you do this like every day, like, and you pull the latest predictions, I think you get, I don't know, 200,000. Like
right, right.
a really really big amount. So we have this script to sort of, and many of them are similar, right? So we have this script to sort of dedupe them by similarity. So anyway, yeah, like so that with that data, with that new data collection process, we got a lot more data, and I think like for the supervised fine tuning step, we now use 400 or 500 examples, which are good
Nice.
enough to like tell the model, hey, this is the kind of stuff that you need to do, and it's not as brittle as the prompt engineering approach was.
And you mentioned that because we're making the data set open, like maybe we should talk about this aspect a little bit. Is like we're kind of like making the bet that I mean, it's okay. Just backing up a step, like all these companies, it's like we're a company. We have salaries. Salaries cost money. Company needs to make money to be able to.
Yeah.
So there's always like a little bit of tension where what every other company that we know of that's shipping features like this is doing is they're keeping it all closed source, and then like this is kind of their secret sauce, and then they can charge for that. What we're hoping is that we can make everything open, and then we can benefit from the general open source philosophy of like, well, we're giving this away, you can use it under the terms of the license, and it's like a permissive license, so anyone can use it. But also that means that anyone can contribute, and so we're kind of hoping that we can end up with something that's better than the alternatives because we can get people contributing to our open data sets, or to the model itself, like fine tuning or whatever. And then of course we still want to charge money, so the idea is like we're just going to charge for convenience. Like we'll set it up on our infrastructure, and we should also probably talk about the
Mhm.
saga of like finding providers and stuff like that. Like the
Yeah.
infrastructure piece is definitely non-trivial, and then the hope is just that like, hey, people will pay for convenience, and it's like, yeah, you could host this on your own hardware, but like, would you rather do that, or would you rather like instead of giving some other provider your credit card, just give us your credit card, and then we can make some money for all the work we put into
Yeah,
this.
and I just like the transparency also for like, because as we keep developing this feature and people use it, we're gonna collect more data and ask people to like for their consent to collect data, and we only do that for open source projects.
Right.
Um,
To
yeah,
be clear, so that means like both
yep,
that we only collect your data if you tell us it's okay to collect your data. So
right,
it's totally fine to say no. And then also we actually look for a license file that indicates that like the data you're giving us is actually available under a permissive
right,
license. Um, so that
right,
like we're not accidentally incorporating like GPL stuff into our code
right,
or
right,
proprietary stuff into our code. Like we
right.
want to make sure that the data set that we've got is just like it's all totally above board, and like it's fine to use that data.
Totally. But, but not only that, right? Like you also see like that data in the data, right? Like being able to see where that data ends up in, I think is also like, I think it's the right call. I don't know. I don't see any other way
It's
of
sort of like
doing it.
everybody benefits, and like the only risk to us because like maybe everybody chooses to host it on their own hardware and not ever pay us, and only pay other providers. But like I don't know, I think people will pay for convenience, and also like I think people will pay to just like support us doing good stuff and get it over with.
Yeah, before we move on to the hosting part, one thing, there's a second step to the fine tuning process, which you were talking about that behavior of like I'm typing something and like the model wants to delete it, or I deleted something and the model wants to add it. Basically, like with as I was saying, like with supervised fine tuning, all you can tell the model is here's the input, here's the output. Period. Right?
Right.
It's very hard to tell the model not to do something. It's like telling the model not to think of an elephant, right? Like it's gonna think about an elephant. And so basically what we do is like we have two steps to the fine tuning process. So we have the supervised fine tuning, which pinpoints the behavior, like I said, and then we have this other step, which is called DPO, direct preference optimization, where like you tell the model, hey, okay, here's the input, here's a good output, and here's a terrible output. Don't do this, right? And so what that process does is like it sort of steers the two apart, right? Like it sort of makes the good one like more likely and the bad one less likely, right? Like so it kind of pushes that the logits, like the probabilities of those tokens lower. And that's been, I think, pretty effective at reducing the number of times that the model is like, oh, you just deleted this, I'm gonna re-add it, or vice versa.
Yeah. And I mean, we also talked about briefly the idea of like, well, for some of these things, we could hard code them. Like we could say like, well, if the thing that it suggested fits this exact pattern, then like
Right.
just throw it away or something like that. But there's problems with that too.
Right, right. Yeah, I mean, yeah, you could say exactly like if I just typed X and the model wants to delete X, then we can filter it out. And I think we should probably still do it because the model still hallucinates that sometimes. But this whole process is like a non-deterministic fuzzy. It's very hard to encode it into an classic algorithm, right? So which is, yeah, the beauty of it as well, though. So,
Yeah. Well, but also, like, ideally, maybe we would prefer it to suggest something else. So it's like we can discard some of its suggestions, but even better is if we can tune it to just, like, give a better suggestion in the first place.
Totally, totally. Yeah, and by the way, like, the model that we're gonna ship with, or depending on when you're seeing this, the model that we shipped is by no means, done, right? I think, like, there's still a lot of improvements that can be made, and hopefully, more data and more people contributing to it, will lead to a better model.
Yeah, so if you're watching this and you wanna help us out, and help everybody out by contributing to our open data set and open source model and open source code that powers the model, because the whole editor is open source too. Uh, yeah, we'll have some links, for, like, where to do that in the blog post. Nice. Should we talk about, infrastructure?
Yeah, this process taught me about what the word scarcity means. Like, I didn't really realized that I read about it. I knew what it meant, but it's really hard to host these models. Like it's not coming from a background of like, oh yeah, I basically grew up in a world where like there was so many servers and CPUs that I could just like I remember my first Rails application. I could just say Heroku push. I forget if it was get put. You could just push to Heroku, right? And then things just worked.
Right, and just magic.
Yeah,
Yeah,
right. And yeah, this is a very different world. As I learned, I think like if you talk about classic like CPU bound infrastructure, like the key players are you know more or less where to look at, right? Like it's kind
right.
of the dust has settled on that front.
Yeah,
GPUs, on the other hand, yeah, it's a very, very different world. So we experimented with different providers, right? And some of them would give us pretty good latency, but they were resource bound. So like
yeah,
resource limited. So you could just deploy 4H100 and then if you need more, then you're left uh, by yourself. Others like had more elastic capacity, but the latency wasn't as good. So it's been a really hard process of like navigating which one to pick, and also a pretty stressful one because, like I said, okay, say that we have a spike in traffic. I still want the latency to be good, and like if you over if you overload like a given GPU, you're gonna get terrible latency. So
right.
yeah, how do you solve that? And yeah, it's been a really interesting process to navigate this. And also like the other thing is being able to sort of assign a certain region to the GPUs, because one thing that we didn't say is that there is like a CPU bound part to this, which is, and it's not even CPU really, but it's more normal classic server infrastructure, which is we basically have like the back end of this running on Cloudflare workers, which means
Mhm.
that all the requests are going to be served at the edge. So like if you're like me, you're in Italy, uh, you know, the Cloudflare worker would probably be like 100 kilometers from here, or I don't know how many miles that is, 60 miles, whatever.
Right.
Be very close, right? And so like yeah, being able to hit like from that uh you know uh uh, like from that server being able to hit a GPU that's in the same region, right, in Europe in this case, as opposed to traveling across the Atlantic. um yeah, it's really convenient. So that was also like a factor in the decision.
Yeah, I mean,
um
that's a huge deal for latency for sure, and it's kind of funny because, I mean, going back to what you said about, like, CPUs and servers, it's like, my mental model has always been, like, when it comes to normal web servers not getting any GPUs involved, it's like, some of these companies just have these gigantic, right? They just have, like, servers and servers for days, and it's like, if I get a traffic spike that's, like, 100x normal, they're like, "Yeah, that's
no problem.
0.00 capacity, so I don't care."
Yeah,
But the GPU world's very different. It's like there's so much demand for GPUs, and there are not, the nearly the degree of, like, racks upon racks upon racks of these things, in comparison to CPUs. And so, yeah, it's just like there just isn't as much capacity available in the world. Like, and
yeah.
so, like, all these companies that we were talking with, they're all kind of telling us the same thing, where nobody is saying, "Yeah, just throw whatever at us, and we'll have great latency and never run out of capacity. It'll be
Right.
totally fine." So everybody's like, "Okay, well, let's talk about exactly what your characteristics are going to be, and here's what we could offer, and here's what we can't offer." And yeah, it's a really different world right now. for
Yeah,
GPU.
yeah, and I think it is better than it was, I think, like a year ago, and I think the trend is that it's gonna become more of a commodity. But yeah, right now it's it's pretty gnarly.
Yeah, if anyone's wondering why Nvidia stock is so high, it's because a million companies are all like, sell us every GPU that you possibly can have. Like, yeah.
Right.
Okay, so the other thing that we should talk about is evals. So for those who don't know, evals are basically it's sort of like unit tests, but for your model, and it's a little bit fuzzier and unit
Right.
tests.
Right. Because it's just like, you have these machines that output text in a probabilistic way, right? So it's hard to write your normal assertion of, given this input, I expect this output to take place. And so, yeah, like in order to assess the quality of the model, you have these evals, like Richard was saying, and the idea with the evals that we have in Zeta is that we basically have, we show the like a bigger model, like we use Claude 3.5 for this. We're like, okay, this was the input, and the actual model produced this output, right?
Right.
And then we ask the bigger model, hey, given this output and given these natural language assertions, so like you can think of it as, one of the evals that you can check out in the repo is like, we're defining this quicksort function and we want the model to recurse to the left and to the right of the pivot, right? Um, and the model could decide to do that in 2 billion different ways, right? Like there's different syntax that, you could do it in various ways. And so as opposed to expecting that, a specific string, what we do instead is we ask Claude, hey, make sure that the model is recursing to the left and to the right of the pivot.
Yeah.
And Claude will give us score that, in the way that, this is called in the literature like LLM as a judge.
Yep.
And yeah, the idea is that, like, you can also see the prompt in the prompt that we give to Claude in the repo. We say, okay, when none of the criteria match, give it a 0. When all the criteria match, give it a 5. And then we have, like, you know pick a number in between when, like, it did some of it, but, like, not everything. And so based on that, like, every time we fine tune a new model, we can be like, okay, like, out of these 40 evals that we've got, 35 passed, right? 35 got a, and I think we determined passed as, like, it got a score of 4 or 5. So, like, the upper end. And so that's a quantitative way of saying, okay, this iteration of the model was better than the previous one.
Right, and these are also different from unit tests in a couple of ways. One is like, so first of all, ideally your unit tests don't flake. These like totally non-deterministic. Um, but also, it's not like we're running these every single time. It's like we're running it every time we do a fine tuning pass, because it's not like
Correct.
we're like so much just looking for regressions as we are just trying to evaluate or eval, like how good
Right.
is this new, like pass that we did. Yeah, and it's a little bit strange because, part of me wants to say, oh, we should try to make this deterministic, and we should try to, instead of using LLM as the judge, we should try to do like the quicksort example. We should be like, well, let's like take the code that it produced and run it and see if it actually did a quicksort, and like, see if
Right.
it was
Right.
correct. The problem is, like, it's like trying to do that for every single one of these examples is a huge amount of work compared to just being like, hey Claude, what did you think of these, and hoping that it averages out to being, about right.
I
This is
think
really cool. Well, yeah, let's kind of wrap up by just saying, like, yeah, we're I guess to summarize everything, it's like we got this really nice UX. We made it integrate nicely with the language server. Also, it's free for now in the beta period, but in the future we do, it costs us money, so we're gonna start charging for it, but not yet. For now, it's free. Anyone can just try it out. Um, and but also it's completely open source. The data set's open. All the training stuff we did, everything is open. You can you can completely reproduce this yourself if you want. And also, we would love it if people would contribute to it, because that's a way that you can make it nicer for yourself and for everybody else. So yeah, Antonio, thanks so much for chatting with me about this.
yeah.
This is really fun. And
Yeah, thank you very much for, hosting this. You're really good host.
thanks. Well, hope everybody enjoys the feature, and you can check it out right now at zed.dev.